All right, thank you, Pinar. So what I first want to do is just briefly introduce myself. My name is Daniel Pilla. I'm a solution architect with Qlik, primarily supporting the New York, New Jersey region. I'm located just outside of our headquarters, which is in Radnor, Pennsylvania, and I've been with Qlik for about 3 years at this point. As well as working with Qlik on a daily basis, I'm also self-taught in Python programming. So this topic is personally a lot of fun for me, as this has been a really exciting time to be at Qlik with the capabilities of our latest release. So without further ado, let's begin. Today I'm going to be giving a presentation overall around advanced analytics in general, which I'll begin with, and then I'm going to be focusing a little more on server-side extensions and how everything fits together. I'll go over the flow, the architecture, and high-level setup for both R and Python, but I'm going to be focusing my examples on Python specifically. Pinar will be covering the examples in R immediately following this part of the presentation. So let me first frame advanced analytics and what that encompasses. Let's have a look at the broad range right here of potential analytical needs of an organization. This range from reporting through self-service and visualization to advanced calculations all the way through machine learning and modeling. Qlik can handle a large chunk of this natively. However, the line starts to get fuzzy on when it might be better to use native Qlik or potentially a third-party calculation engine. While there is some overlap, there are, of course, many scenarios that clearly dictate the need to use one or the other. For example, if I'm interested in learning or looking at a statistical distribution calculation or, let's say, correlation analysis, I could use Qlik potentially, or I could use another engine. But now I have the ability to choose. However, if I need to run data through predictive models, I'm going to use a third-party engine more than likely. We're now able to cover this entire spectrum as you simply plug in whatever engine you need to run any calculation you'd like. So some common use cases, obviously this goes across all industries. So from manufacturing and high tech with demand forecasting through healthcare, patient admissions, lots of use cases in financial services from fraud, from credit risk analysis, all the way through to the public sector, life sciences, utilities. There's, again, a very, very broad range of data science use cases. But what we're seeing is people are a little stuck in the old ways, and then they're all of a sudden getting pushed into this new way. So the old way generally was data scientists were typically siloed. So if the organization, and that's for if the organization even has a data science team to begin with, these data scientists would typically do, let's say, 90% of this work from data acquisition through data prep, through model creation and testing and selection, all the way through presenting these results. At this point, it was then up to the business analyst to interpret these results and make changes reactively. But they weren't really involved in the entire life cycle beforehand. However, now we're seeing this global shift in these responsibilities. So much more of the work is now being transitioned to and handled by the business analysts and users. There is, however, a large knowledge gap here that needs to be bridged. The data scientists are still extremely valuable, if not even more valuable than ever, but we are now seeing a very high demand for the business to have much more input, oversight, and interaction with data science. With this, business users want to be able to choose their models, adjust parameters, run different scenarios against different subsets of data. All things that would have to have been back and forth requests traditionally from the analyst to the data scientist, which could take potentially weeks. So after going over advanced analytics as a whole, I now want to focus specifically on server-side extensions and where it fits in with Qlik. So server-side extensions, they allow Qlik to communicate directly with any third-party engine or service. This is a line of communication directly hooked into the QlikSense engine for which data can be sent and returned over in real time. Imagine you don't already have a regular expression in Qlik. We don't have one. Well, R does, and Python does. So let's simply just plug into R or Python and pop that expression directly inside of Qlik. You could either have that function defined, like r.regular expression, or you could even just paste in whatever exact code you had in R and leverage that directly inside of Qlik. So it's that ability to augment Qlik's capabilities with capabilities from potentially another engine. But the beautiful thing is that you're not just tied to R or Python. These were just the first two examples that were built. Already, since its release in June of 2017, examples have already been built in C#, in C++, Java, Go, and more. So I'll dig into that framework specifically and talk a little bit about the architecture of how all of that works in some slides to come. So I consider our approach to be especially unique because we aren't just viewing the results side by side. We're actually combining that data with the Qlik associative engine. So if you are leveraging functionality from a server-side extension on the front end of Qlik, you have the full capabilities and power of the Qlik Sense associations, with data being sent and returned to another engine in real time. This allows you to drive selections and focus with the insight and clarity that you're typically familiar with experiencing inside of Qlik. So this isn't something that just lives side by side. It's actually part of the overarching model within Qlik. So how it works at a high level, and I'm prefacing again in the front end. As we'll see, this functionality can be placed in different functional areas. But on the front end, essentially a user interacts with that application just as they typically would any app. The hypercube is then recalculated in context to whatever those selections were just made, so that subset of data. That data is then sent off to, again, any external engine. This could be Python, this could be R. It does whatever processing, runs whatever commands it needs to, and then ships back that new or altered data set back to Qlik and actually hooks it into the engine itself. So if set up properly, you can actually make selections on data that was returned from Python or R. So it's actually a part of the Qlik Sense engine. And then finally, it's visualized in whatever mechanism or whatever means you'd like inside of the app. Now, in my personal opinion, I see three functional buckets and use cases for server-side extensions. Again, other people's opinions might be slightly different, but what I've found is, number one, at the root, quite frankly, this isn't what server-side extensions were designed for, but it does fill a gap. So for any of you Qlik View gurus or even Qlik Sense with legacy mode, there was the ability to use what was called the execute command, where you could trigger a command line task to run. You can actually configure server-side extensions to just, let's say, call a Python script that starts some external function. So think of this as being a trigger from the ETL, even, let's say, triggering an end printing report to be run or something along that nature, triggering some task to be executed. So kind of a little bit of a not intended purpose, but still very, very valuable because we now don't need legacy mode in Qlik Sense, and you don't need to be calling or giving users the ability to call something from the command line. Much heavier use case would then be integrating functions directly into the ETL. So what I was just talking about prior was front-end use. This is now the back-end use. So let's say I want to leverage some functionality in Python or R, but there's no real benefit to having that be in real time on the front end. So the two examples I gave were sentiment analytics. If let's say I'm loading in tens of thousands of tweets or Facebook posts or Yelp reviews or whatever that might be, that text isn't going to be changing on the front end. So there's no point in doing that more than once. So anything like that, even like a geocoding of a coordinate, you can do directly, call it inline from the ETL. So every single record, it has this new sentiment function and it loads in the results. And the result is just a data point as if it was from any other data source. So this is extremely common. Even, let's say, running records through scoring models and loading in the predicted binary result. The front end is really what we market and advertise because it is, in my opinion, the most exciting. but it's essentially that concept that I just showed. A user makes a selection, it then takes some subset of data in real time off to Python, off to R, and returns it. You obviously want to be aware of some cautions here. So you don't want to have a function in Python or R that takes 10 minutes to run. Obviously, you want it to be snappy because you want the user experience to be good. And you also want to make sure that it's in the right context. So for instance, a really good example would be time series analysis. So I want to do, let's say, an ARIMA forecast on a selection of data. So as my selections are changing, it actually makes sense to reprocess that data and re-visualize it based off of the subset. So there's different times and approaches when you would use this on the front end. Finally, every organization that I've spoken to has significantly different needs. So number one, some larger organizations, they might already have a data science team. They already have all of their models, and simply what they want to do is run all of their new records that come in against existing models and load in the result. Maybe there's nothing on the front end. They just want to leverage what they already have in place. We can do that. Or maybe some people, they might have maybe one data scientist on staff. They want to do a little bit on the back ends, maybe a little bit on the front, but they have some users that want to be able to leverage bits and pieces of what they already done. So of course, we can leverage the ETL work. You can, of course, do that on the front end, but this is requiring at least a little subject matter expertise for someone to build and actually know how to write R script or leverage an existing Python function. Finally, there's also a significantly wide area of people that don't necessarily have any experience with predictive or any necessarily staff on hand. With this, some of our internal architects have actually built out extensions that are able to automatically generate R script or interpret those measures and expressions and build the R script dynamically. So that way, to an end user, they just put, I want to see my sum of sales, my sum of costs, and my total quantity, and give me a k-means cluster. But they might not have any idea how to write a k-means cluster function in R, but all of that can then be handled on the back end. So there are use cases from the most developed organizations all the way through organizations that just need a drag and drop. Give me a quick predictive forecast on this. I don't necessarily care what model is being used, for example. So a general SSE overview. I'm going to get a little technical now and talk about the integration specifically. So Qlik has chosen to leverage the gRPC protocol for its server-side extension implementation. This protocol serializes data so that many different languages can consume it in a standard fashion. There are many languages that can interpret and leverage this protocol, including Python, Node.js, Java, C#, Go, and others. What you'll notice is that for these languages, there isn't any connector, if you will, as this communication is done directly from Qlik Sense to whatever listener you're using in that language. This makes it extremely flexible and lightweight, as we are using a standard and not a Qlik-specific connector of any sort. R is a little bit different, so I want to take a little time to talk about this, because gRPC isn't directly supported or available in R. So here, Qlik R&D has built a bridge in C# that translates the gRPC serialization into something that R can then consume. So this bridge is open source and again simply acts as an interpreter. The benefits, however, in my opinion, using gRPC for many other languages outweigh the minor overhead required of this extra piece for R. Lastly, I just want to talk about some considerations, and again, there are more than this, but just make sure you architect your deployment with these considerations in mind. So number one, again, overall calculation times. This is going to be based off of concurrency too. So for example, make sure that your responses, if you're doing something on the front end, are relatively quick, because if you have dozens or hundreds of users, you don't want things to start to bottleneck or jam up. You want to make sure that you have the right subject matter expertise. So these algorithms that you're defining, the R functions, the Python functions, are as optimally set up as they can be, because obviously at this point, the data is being sent outside of Qlik. So the performance is going to be dependent on how well that those algorithms are defined, as well as what services you've set up and how you've broken them apart. So for example, you could have a Python service with 20 different functions on it, or you could have 5 Python services with 4 different functional functions each. So you're relieving that bottleneck across different ports as opposed to having them all sitting on the same port. So be sure to think about those type of architectural questions and considerations as you're setting up server-side extensions. All right, so you'll now notice I'm in the browser. I'm in my local QlikSense server. I just want to point out really briefly that there's a new Analytic Connections tab under Manage Content, starting with the June 2017 release and plus. This is where in QlikSense, you'll establish your analytic connections. If you're using QlikView Desktop, QlikView Server, or QlikSense Desktop, all of these analytic connections would be added in the settings.ini file. And there's a format on how to do that on help.qlik.com. These analytic connections, and you can see I have a number of them for Python, so you're not limited to a single service. And I have one for R at the bottom, is pretty straightforward. You just simply put in the name of that analytic connection, the host, so whatever server it's running on. In this case, I have it running on the same instance. The port, which can be configured on the Python side. And then if you want to have that secured and locked down, the communication between, you actually can add a certificate to that if you'd like. This is actually a big differentiator. So this analytic connection, not only the traffic, but you can also see that I can add custom properties. So I could actually lock down who has the ability to leverage the analytic connections on the QlikSense server. Now I'm going to head over to my hub, and I'm in the advanced analytics stream, and you can notice a lot of different apps here. So I'm going to focus specifically on Python, and then after the fact, Pinar is going to be showing some R examples. I've already got these open in tabs, so I'm going to start off with a basic sentiment analysis app. So what this is doing now, go ahead and zoom in a little bit. There we go. I'm using what's called the Vader sentiment package. It's a open source Python package where here on the front end, just to show you in real time, I can run sentiment analysis on text. But what you would probably want to do is run this as, again, through the ETL, because this text isn't going to be changing. But this is a cool real-time example to show how input can directly be sent and returned to Python. So if I say, let's say, wow, this is a great webinar, hit enter, you can see that that text was then returned. And I have a JSON block to show how positive, how neutral, how negative it actually was, and then my overall scores returned beneath. If I add, let's say, another exclamation point, hit enter, I can see that got just a little more positive overall. But more of a real-world scenario would be, okay, well, now I took 50,000 article titles and ran them through in the ETL. And I've loaded in how positive and how negative and the compound scoring as simply new fields in the actual application. So I can now filter on them without having to do anything in real time. And it's kind of funny. I can see some of the UK news sources are a little more negative than, let's say, BBC Sports or MTV News or TalkSport or any of that. And I can always go in and look at specific articles and start to drill in, again, in memory without having to go back to the engine. Now on the ETL side, quick note, you'll notice IntelliSense hasn't caught up quite yet to the new analytic connections, but there's nothing wrong with this statement. But here, you'll see I have a new function type analytic connection called Python sentiment. If I go back to my management console and click on analytic connections, there it is. So it's saying use this analytic connection and use this function defined externally in Python called sentiment. So I built that function. It has 2 parameters. It takes whatever the text is. In this case, I'm using my article title field. And it takes another arbitrary parameter. It could be all, or it could be POS for positive, NEU for neutral, and you could define any function you'd like. So I've chosen to run it once where it returns that JSON block, and then I can just parse out all of the different functions. So rather than running 5 different functions on Python, I've run one, and then I use Qlik to parse out all of those new fields, again, generated directly from Python, that I have available inside of my data model. Moving on, this is a basic ARIMA forecast function in Python. So basically I have my historical data in yellow. I have how many months out I want to forecast as a variable tied to this range slider, and you could see that forecast in blue. So as I change that to, let's say, 5 months, again, it goes out to Python, it re-renders that forecast. Let's put it back out to maybe 11 months. And now you can see that that forecast is going to be adjusting on every single click I'm making. It's also still tied to the engine, though. If I just want to look at a specific product 2, again, I'm looking at only that subset of data, and you'll see that my forecast shifts. Linear regression, we can actually do this natively, but I think that this is a good, clean, simple example, way to show calling an external function in Python. So again, select an arbitrary number of categories, and I could see my linear regression line both on a line chart or on a line chart with dots below as well. When I click on Edit and check out that function, I can again see my analytic connection as Python regression. My function is called linear regression. I have my sum of sales. Now, this, in my opinion, is clean. You can, however, and like what you'll see in R, just put in Python code here if you'd like. With R developers and programmers, frequently that's the way they'll do it. It'll be R dot, let's say, script eval and a big chunk of R code. Or you can always define functions externally. With Python, a lot of times people want to use their own editors. Since it's a white space delimited language, it can be a lot easier than trying to put that inside of the expression editor. So that's an example of that. Finally, I want to focus on, let's say, churn. So this is a great example of a organization that already has models, that maybe they have a data science team, they've created a K nearest neighbors model, a random forest model, support vector machine model, and they say, I want to run through, even in the load script or in the front ends, subsets of data and show the different variances of predictions against my different models that I've created, which typically a data scientist would have to do, and a business user would never have the ability to do that. So I've configured this application to first select a single model. So if I select random forest, it now sent this small subset of data, which are my new records, to predict. And you can see my Python prediction column here and where it matches. So in this data set, 8 of these people churned. So they left that service. Python was able to predict 6 out of 8 of them. So it was 75% accurate with the random forest model, 94% total accuracy. But you'll see here, you have a 2.2% inaccuracy, where it actually predicted someone would churn when they didn't. So what I might want to do is say, okay, well, maybe that's not the best model for this subset of data. So what about K nearest neighbors? Here you'll see it only got 5 out of 8 correct, but it didn't improperly classify anyone as going to churn. It got everyone that didn't churn correct, but it didn't get quite everyone that did. SVC, however, got 6 of those 8 people correct. It didn't get this guy, but it did get this one, which random forest didn't get, and it didn't get anyone wrong either. So it's 96% accurate. This is more than likely the best model for this individual scenario. I could also then go over to my next sheet and compare all models simultaneously. So this is now running that same data set against all 3 models and then comparing their accuracy against one another. So here I can see my overall accuracy, my inaccuracy, and how much it predicted churn, or how accurately it predicted churn by model, potentially even by area code. So I can use the associative engine to start to drill in and compare models off of subsets of data using Qlik, which in my opinion is extraordinarily powerful. Now, what we focused on so far has been what I would deem as more of the advanced analytics. But let's say you just want to do something maybe to use Python as a bridge. So it's not a traditional statistical function or anything of that nature. Let's say I want to geocode. Here I'm showing using geoanalytics. I have a geocoding function where if I put in our address, 150 North, Radnor Chester Road, Radnor, PA, hit enter. It then goes off and geocodes, and that is indeed our building that our headquarters is in. I could do this from the load script. I can do it from the front end. And this got me thinking, okay, well, what about directions? So now I have a data set of all of these addresses, and let's see, I need to go from one to the other. As soon as I select that, and I'll have to fix that after the fact, I could see my list of directions. I should be able to see my drive times. Let's try maybe 2 other ones. There we go. Now I see my list of directions, my duration in minutes, my alternative route, and my distance in miles, and my distance for my alternative route. So pretty cool use case here. Then I was actually asked from a client, can you solve the traveling salesman problem? And in my opinion, as long as there's a service out there that's able to do it, Python is just a programming language. It can talk to pretty much any service you'd like. So again, I have an example here where I've set up Qlik to basically be the UI, but using Python to fetch and render all of that process data. So it's not like I'm running any statistical functions. I'm just using it as a bridge for any additional external service to process any data I'd like. So if I put in, let's say, and you'll notice we're embedded in Salesforce as well in this. I put in Portland, Oregon. It's dropped a pin at where that is, again, using Python. And let's say I want to use Qlik to whittle it down. So I only want to look at prospects in, let's say, Oregon. And I've set this up where if I select between 2 and 10 points, it's going to kick off this traveling salesman task. So if I go ahead and lasso, let's say, this area, it now, again, in real time, goes off to Python and calculates the most optimal route to then traverse to that client. And if I was feeling pretty adventurous, I could say, you know what, let's bike. So I then have the ability as a business user to start changing parameters of that function as well. So this might not be a use case that you have, but I like to show it because of the fact that Python can truly be a bridge out to any service you'd like. It can kick off commands. It could trigger internal processes. You can use your own internal Python Flask REST API if you wanted to and run things against that. It doesn't have to be the traditional statistical or predictive use case. It opens up a lot of different options. So with that, Pinar, I'm going to pass it back to you. And thank you all.